Today we will see how to draw the Bode plot for the transfer function k by s, where k is a constant, it can have any values, and we have a denominator, s is in the denominator. So if you take a Laplace transform for the integral, we will get the equation in terms of 1 by s. So we are going to solve in terms of integral plot. So the first rule in order to plot for the Bode plot is we have to substitute s to j omega. This is what first step we have to do. Then once we substitute this equation, then the transfer function will become as k divided by j omega. So after this we have to find the gain and the phase equation. So in order to find the gain and the phase equation, so here the variable parameter is omega. So the omega is changed from, let's say for our analysis, is 10 power minus 2 up to 10 power 4. We can change anywhere. So that depends upon what is the value of omega we are going to choose. Now before going to change the location, I just want to highlight, if I have this one, so what is the root location here? So here we have to identify whether it is a pole or 0 first. So since it is in a denominator, we can say there is a pole available for us. Okay, so what is the location of the pole? So if I take this one, if I write s becomes 0. So my location of the pole is at 0. So that means at the origin I have a pole available for us. Now if we calculate the gain and this one, so how we can calculate here is, so before going for calculation of the gain, so gain is given as 20 log of mod g of j omega into h of j omega. So if we take the mod of g of omega, h of j omega, but in all our analysis we'll assume that we have a gain, open loop gain g, and I have a unity feedback. So that is the first thing we have to. So this is our input. So we always have a unity feedback. If I have unity feedback, then h of j omega, the value will be equal to 1. So that means I have to take only the value of 20 log mod of g of j omega. So when I say mod, so what happens here? So mod of g of j omega is nothing but I have to take mod of 1 by square root of real term plus imaginary term, the squares. So what is the real term available here from the equation? Okay. So it is transfer function is k by s, so there is no real term, so I can write it as 1 by 0 square plus what is the imaginary term will be of omega the whole square, so which is nothing but 1 by omega. Okay. So k is in outside here, so if I bring, so the value becomes k by omega. So this is the term we have used here. So this is the final expression is 20 log of k by omega. Now we will substitute the value of omega and see what is the value we will get for the gain. Okay. So we have changed omega. So just to cancel out the k, we have taken the values k divided by 10k and 10k. So if we substitute the first value, so k will get cancelled, so I'll get the value of 20 log of 10. So if I have 20 log of 10, so the value is so log of 10 value is given as 1. Okay, then 20 log will be equal to 24s. So that's the value we have. Now how to calculate the phase? So to calculate the phase, so it is a tan inverse of imaginary part by real part. So what is the imaginary part available here is omega. So here imaginary part is omega. So what is the real part? Real part is 0 for us. So if I substitute this here in phi, will be equal to tan inverse of omega by 0. Okay, and the imaginary part, since the imaginary part is in the denominator, there is a minus sign comes here. So minus tan inverse of omega by 0. So if you do this one, so what is the value you'll get? I'll get the value of minus tan inverse of infinity, which is equal to minus 90 degree. So that is the value we got here. So similarly, if I substitute the k, then what is the value we will get? So we'll get the value as 1 log of 1. So when it is a log of 1, that becomes 0. So we'll get the gain as 0. When it is 10k, so it becomes 20 log of 0.1, which is nothing but equal to minus 1. So we'll get 20 log means we'll get the value as minus 20. So the phase will not change. There is no change in the phase, whereas in the gain there is a change. So if you look at the difference between these two, okay, when we look at the difference between these two, so it is clear that there is a difference of 20 dB is there. So in the sense there is a minus 20 dB is there, right? So it keeps on decreasing from here to here. It decreases by minus 20 dB, and here also it is decreases. So from 20 it decreases every time. So that's what we have said, there is a change. Now we'll try to plot in the Bode plot. So as we have told, this is the semi-log graph. When I say k divided by 10, okay, so let us plot for the first scenario, k divided by 10, when omega is equal to k divided by 10. So what is the value of omega will be equal to k divided by 10. If I assume the k value is equal to 1, let's assume k is equal to 1, then the omega value will be equal to 1 by 10, which is equal to 0.1 for us. So this is what is represented in here. It's a frequency domain. So at 0.1, so when it is a 0.1, so we are going to plot here. So this is the value of 0.1. So what is the value we got at 0.1? So it is 20. So it is in a positive direction. So here I am going to mark here as 20. Okay. Now what about when omega is equal to 1? So when I say omega is equal to k. Now we are taking k value is equal to 1. So again, which is equal to 1 for us. So then means 10 power, so 10 power 0 is equal to 1. So here I got the value as 0. So similarly at 10, so I got the value is minus 20. So if I draw the line here, so this will be the line, and if I extend, so I'll be getting for other values, you can verify this. So for 10 power 0 it will be minus, and 20, 30, 40. So this will be the graph we'll get. So for the phase, we'll get exact. There is no phase change for all the scenarios, so I had to draw exactly on the 90 degree. So this will be your phase and the gain in a Bode plot for the expressions k by s. So here we have taken the k value is equal to 1. If the k value changes, accordingly you will change the gain value. Now the question comes is, what happens if the k value changes? Okay. If the k value is there, for example, if you take k value is equal to 2, let's assume k value is equal to 2, how can I easily calculate this value? So the expression says is gain value is 20 log k by omega, right? So this expression I can rewrite it as 20 log of k minus 20 log of omega. So by this I can calculate this 20 log of k separately, then I can calculate this 20 log of omega separately, then I can find the values. For example, if the k value is equal to 2, then the 20 log of 2 value is 6 point. So let me take the value as 6.02. I am roughly taking the value as 6. So now from the value of 6, what is the value of omega you got? You have to just subtract and you have to plot the values. So this is the technique we will be following to plot the Bode plot for the given transfer function of k by s.